All right, hello everyone. Today we're going over a practice test on regular polygons. Okay, so yeah, question one. The measure of one angle of a regular 13gon is, and we have to pick one of these four options here. Okay, so what we're dealing with here is a regular polygon that has 13 sides. Now remember, the measure of any regular polygon could be found using the formula n minus 2 times 180 and then divided by n. Okay, now in this case, remember n stands for the number of sides, which in this case is 13. So we're going to take 13 minus 2 times 180 and divide that by 13. Okay, now 13 minus 2 is 11, so 11, let me put my equal signs here. Okay, 11 times 180, and then we're going to divide that by 13, and that's going to come out to 152.3 degrees. So that's B. Now on to question 2. Okay, so we want to know the sum of the interior angles of a nonagon. Remember, a nonagon is a polygon with 9 sides. Okay, so in this case, our n is equal to 9, right? And we want to know the sum of the interior angles, not the measure of just one of them. All right, so the formula for this one, okay, is going to be n minus 2 times 180, and then now we're not going to divide by n. Okay, it's just that numerator from the kind of last question. Okay, so n minus 2 times 180. So in this case, like I said before, n is 9, so we're going to have 9 minus 2 times 180, and that's going to come out to 7 times 180, and that equals 1,260 degrees, which is D. All right, moving right along to question 3. So each side of a regular heptagon measures 17 meters. The measure of the apothem is 17.65. This should say meters. What is the area of the heptagon? Okay, so now we're no longer looking at just angles. We're looking at the area of a regular polygon. Which polygon? A heptagon, which means that the n, right, is equal to 7. There's 7 sides, okay? Now remember, the area for any regular polygon is perimeter times the apothem divided by 2. But if you look at the question here, they don't actually give us the perimeter, right? So we have to figure that out. Now we know for this regular heptagon, all the sides measure 17 meters and there's 7 sides. So if you want to know the length all around that heptagon, you're going to take the perimeter is equal to 7 times 17, right? The number of sides times the measure of each side. If you take that multiplication out, that's going to give you 119 meters. That is your perimeter. Now you know that your perimeter is 119. You can take that number and plug it back into your formula. So you have 119 over here times your apothem. The question tells you what that is. That's 17.65, and you're going to divide that by 2. And that's going to come out to 1,050.2 meters squared. So that's B. Right, on to question 4. So which of the following is not a polygon? Now remember, for a polygon, okay, polygons are shapes, 2D shapes, but there's 2 main properties, right? And one of them is that they have to be closed shapes, okay? And the second one is that all the edges, okay, must be straight. Okay? It has to be made of all straight edges. So let's think about a square, right? A square is a closed shape and all the edges are straight. So this one is good. Okay? An equilateral triangle, that's also a polygon because it's a closed shape and all the edges are straight. So this is great. Same thing for a scalene triangle. Okay, a circle, sure, it's closed, but it's definitely curved and not straight. So C would be the answer here. It is not a polygon. So question 4 is pretty straightforward. No math is involved. You just have to remember the definition of a polygon. All right, so on to question 5 then. Right, so question 5 is asking us to determine the missing angle ABC in the polygon below. So that's this angle right here, that ABC, okay? The angle with the X. Okay, so we don't know what that is, but we know the angles like the four other angles here, right? So let's add them up real quick, see what that gives us. Okay, so we've got 95 plus 123 plus 117 plus 86, and that's going to come out to 421 degrees. Now, we know the angle of these, the sum of these four, okay? And we also know that because this is a polygon, in fact, it's a pentagon, okay? You can find the sum of all the interior angles using the formula that we used earlier on in this test here, okay? Remember, the sum of all interior angles is equal to n minus 2 times 180, okay? And remember, this formula works even if the polygon is not regular, okay? The sum of interior angles formula works for any polygon, okay? So I mentioned before, this is a pentagon, which means that n is equal to 5. So 5 minus 2, okay, times 180, that's going to be equal to 3 times 180. That comes out to 540 degrees. So if I took all these 5 angles and added them up, that's going to come out to 540. And because I know that if I add those 4 angles up, okay, and it comes out to 421, then this x here just has to be the difference between those two numbers, right? So x, okay, that missing angle, is equal to 540 minus 421, and that's going to come out to 119 degrees. Now on to question 6, okay? So we want to determine the area of the following regular polygon, right? So remember, the area for a regular polygon is equal to perimeter times the apothem divided by 2. So first things first, okay, we have to find what the perimeter is. And to find the perimeter, we're going to take the number of sides times the length of each side. So we already know that the length of each side is 6.68, right? And we know that because it's regular, so all the edges have the same length. We just have to figure out how many sides there are. So let's just count real quick. We got 1, 2, 3, 4, 5, 6, 7. We got 12. Okay, we got 12 sides. We're going to multiply that to 6.68. Okay, and that's going to come out to 80.16 meters. All right. Now that we know the perimeter is 80.16 meters, okay, we're just going to put that right here in this formula, 80.16, and we're going to multiply it to the apothem, which is given here. Remember, the apothem is the distance from the center of your polygon to the middle of one of its sides, okay? So that's going to be 12.91, and then we're going to divide that by 2, and that comes out to 517.43 meters squared. Okay, question 7. Determine the shaded area in the figure below. Okay, so we've got this pentagon here, and then we've got like a square that's been cut out of it. And we know the apothem of the pentagon is 6.88, and the side length of the pentagon and the square are 10 centimeters for both. Okay, you can see those two lines kind of overlap here. Okay, so let's start by finding the area of the pentagon, and then we'll find the area of the square that's been cut out of it. And to find the shaded area, okay, that's just the area of the pentagon with the area of the square removed from it. So we're going to subtract the area of the square from that pentagon, okay? So first things first, let's start with the pentagon. Okay, to do that, we have to do the formula that we used before, perimeter times apothem divided by 2, okay? So let's just do it all in one step here. The perimeter is equal to 5 times 10 times, and now the apothem is going to be 6.88, and then we're going to divide that by 2, okay? And that comes out to 172 centimeters squared, okay? So that's the area of that pentagon. Now let's find the area of the square, okay? And for the area of the square, we don't have to use this formula. You could if you really wanted to, but remember, the area of a square is just the side times itself, right? The side squared. So we're just going to do 10 times 10. That's going to come out to 100 centimeters squared. And now, like I said before, we're going to subtract, okay? So we're going to take that 172 minus the 100. That's going to come out to just 72 centimeters squared. And that's the area of that shaded region. All right, question 8. Determine the shaded area in the figure below. Okay, so this is very similar to the last question. We've got a shape and then a shape that's been cut out of it. In this case is a triangle with a circle that's been kind of removed. Okay, so if we want to find the shaded area, we're going to find the area of the triangle, take the area of the circle, and subtract that from the area of the triangle. Now, if you want to get started and you're like, okay, let me find the area of the triangle, you might notice that, we don't have the height. And if we don't have the height, we can't use base times height divided by 2, which is how you would normally find the area of a triangle. But you might notice, okay, this dotted line here is not just the radius of the circle, it's also the apothem of your triangle, right? It's the distance from the center to the middle of one of its sides. Okay, so because we know that 2.31 distance, we could use the formula area is equal to perimeter times apothem divided by 2 to find the area of your triangle. Okay, so perimeter is the number of sides, which is 3 in this case, right? Times the length of each side, so times 8. That's your perimeter. Now we're going to multiply the apothem, so that 2.31, and then divide that by 2. And that comes out to 27.72, okay, centimeter squared. Now the area of the circle, okay, you can use pi r squared. So 3.14 times 2.31 squared. Remember, squared means times itself. Okay, so on your calculator, you could do 3.14 times 2.31 times 2.31. Or if your calculator has that like squared button, you can just click that right there, okay? And that's going to come out to 16.76 centimeters squared. And all that's left to do now is to subtract. So 27.72 minus 16.76, that's going to come out to 10.96 centimeters squared. All right, question 9. Mr. Hum is designing a large decorative garden for a public park. The garden consists of a regular hexagonal fountain area in the center, surrounded by triangular flower beds, one along each side of the hexagon. The budget allocated for the landscaping project is $45,000. The fountain has 6 equal sides, each measuring 8 meters, and the apothem is 7 meters. Each triangular flower bed is a triangle with a base of 8 meters and a height of 4 meters. The cost of building the fountain is $150 per square meter. The cost of building the flower beds is $200 per square meter. Will the total cost of the project stay within the $45,000 budget? Okay, so the game plan here is to find the area of each of these kind of segments, the green segments and the blue segments, and we're going to multiply them to their respective cost per square meter. Once we have the cost of the hexagon and the cost of those green triangles, we're going to add up those costs and see if it comes out bigger than or less than that $45,000. Okay, so step 1, let's find the area of that blue hexagon. Okay, now this is a regular hexagon. We know the area for that, right? It's equal to the perimeter times the apothem divided by 2. So the perimeter is just the number of sides, which in this case is 6, times the length of each side, which is 8, times the apothem, right? So that 6 times 8 is the perimeter. Now that's 7 is the apothem. We're going to divide that by 2. That's going to come out to 168 meters squared. Okay? Now let's find the cost of that blue hexagon. So we're going to take the area and multiply it to the cost per square meter. Okay? So that's 150. And that's going to come out to $25,200. Okay. Now step 3, let's find the area of all of those green triangular flower beds. Okay. Now because they're identical, okay, each of those green segments is identical, let's find the area of just one of those triangles and multiply it by 6. That's going to give me the area of all 6 of those triangles. Okay. So the area of a triangle, remember, is base times height divided by 2. So the base in this question is 8. The height is 4. So we're going to multiply that out and divide it by 2. and that's going to come out to 16 meters squared. Now step 4, okay, is to take that 16, that area, okay, and we're going to multiply it by 6 to get the area of all of those flower beds. That's going to come out to 96 meters squared. Now step 5 then is to take that total area, the area of all of those green triangles, and multiply it to the cost of the building the flower beds per square meter, right? So multiply by 200. And that's going to come out to $19,200. Now we know the cost of building that blue fountain, right? That blue hexagon, and we know the cost of each of the all of those flower beds, okay, combined. So step 6 then is to add those two costs together. So 25,200 plus 19,200. That's going to come out to $44,400. Okay, now we have the total cost. We know the budget, the amount of money we have to work with, is $45,000. This is within the budget. So yes, it will stay. Oops, let me scroll down a little bit. Okay. It will stay within the $45,000 budget. And then you can put a little smiley face too. Okay, and that's going to wrap it up for the practice test. As always, if you have any questions, just leave them in the comments below. And yeah, have a great day. Bye.